Let's make sense of this.
Let's make sense.
Sense makers.
Hey Ken, welcome back.
Hi, Matt. Thanks for having me.
For sure. So we're just going to wrap up regression here, part 2.1 on the Alteryx Expert exam, and this is going to be on approach. So approach for this exam, we've just got one slide, but I think is really some pointers that I think are going to be valid for the exam. You're going to want to practice, of course. You're going to want to practice with classification type tools, predicting yes, no, predicting order, predicting regression, which is numeric. They mechanically are going to follow similar steps. The only thing that's going to be different is that your output is going to be either numeric counting or it's going to be a yes-no classification. So just being comfortable with that, doing the weekly challenges that are listed as difficult or targeted for the predictive exam or for the expert exam is going to be essential. The second point I want to make is that you're going to want to follow the instructions closely. As much as this is an exam about knowing how to solve the problem, it's an exam about following the instructions and doing the things they want you to do. Because quite often they're going to be very explicit about certain things they want you to do. For instance, they might say, we want you to run a model comparison between a logistic regression, a support vector machine, a gamma regression, and a spline model. They might give you some sort of combination. Decision tree, random forest, etc. They might be explicit. They might say other things that might not be as explicit. And so from there, you just have to be able to kind of follow context clues and just make sure that each tactical step that you're doing, you're checking the box. And what I like to do is when I have a problem that has multiple steps, I'll copy all the steps, put it in a comment box, and then I'll just go one by one. And then once it's done, I'll either write done or I'll just draw a line through it and then confirm that that step is done. It might take a little longer start to finish, but it'll give me that confidence that I explicitly am doing discrete steps, because the temptation on an exam, and the temptation is when the clock's working against you, is to combine steps or to skip steps and to try and rush, which is going to be a temptation because you have to move and the clock is against you. It's going to be very difficult to want to slow down and be procedural. But what'll happen is that inevitably you'll make a mistake. It's very difficult to do a difficult problem without making some sort of mistake. It's about identifying when you make that mistake, where is it, and then how quickly can you debug it. And if you take your steps one by one and see the before and after like Alteryx does so well, it's going to be easier to debug versus if you're just trying to do step A, step B, step C, step D, and then you're not looking at your data along the way. You're not validating that you're doing the steps the way you're supposed to. You get to the end, and the result is not matching what you're expecting. And you have no idea where that breaks.
Matt, that is such great advice. I want to tell you a little bit about a short story that happened to me back in 2017. I went into a top coder competition completely ill-prepared. All I had was Alteryx, and I didn't have any compilers. I didn't know what the format of the competition was, but I quickly realized that I was in deep on, in not a good way, in deep on this top coder competition. There were 6 problems. I couldn't solve any of them. They were overwhelming. And so what I figured out in the context of the 2-hour exam, as you just explained, you don't try to solve the whole problem right from the beginning. Break it down into little tiny wins. And if you do that, you'll begin stacking those wins. And then suddenly, before you know it, you'll have the first problem solved. And then the other problems become just another challenge. You write algorithms, you do things that you've been trained to do, things that you've learned throughout your life in terms of how to problem solve. And you take those techniques and you apply them, and then before you know it, you're done. But if you try to solve the whole thing without doing that, you're going to be in trouble. If anyone's interested, just you could look at my blog, datablends.us, and look at lessons learned during a top coder competition. And you'll see, although that was written in 2017, what Matt just said is almost perfectly in sync with what I went through so many years ago.
So I've done the Grand Prix twice as a competitor, and I've done the expert exam, I've done the predictive master. I will say that there is a slight difference in approach that I had to take when doing Grand Prix, because you're racing against 5 other people or 4 other people or 100 other people if you're qualifying. And sometimes, like doing what I just described there, I don't think you'll have the time to do that there, because you have to get some of these problems within 5 minutes or 6 minutes or 7 minutes. So you have to like be much more efficient. But with this exam in particular, you're going to have, if you do the math correctly, 30-ish minutes. And when you have 30 minutes to do a problem, your approach is going to be very different than if you have 5 minutes or 3 minutes or 3 hours. The more time you're given, and the more time you allow yourself on problems, the more procedural you can be and the more detail-oriented you can be and more mechanical. And so that's where, like, on these problems, because they are mechanical, and if you practice the tools and know how the logistic regression works, the linear regression works, and a lot of the tools are basically you drag it on, you check boxes for what features you want, you select your target variable, you're off to the races. And then what I like to do on the exam, or what I recommend people do on the exam, is to take that time, because you do have 30 minutes, maybe 20 minutes if you're running long on another problem. You don't have to feel rushed. These problems shouldn't take that long. So what you can do is save your workflow frequently, because what that'll do is if you are doing step A, then step B, then step C, then step D, anybody that's worked in Alteryx long enough knows if you aren't saving, it can crash. It crashed on me during the exam. It happens. And then you have to go through the auto recover files and figure out where it exists, and you're already flustered. And if it's got relative paths that are now broken, it could be a whole mess. But you can save yourself some heartache by just saving the files where you need to save them, which are going to be in the instructions. The other tip that I had for these is that sometimes running these model objects, especially if you have to run a tournament of models, like 4 models or 5 models or 6, and then you have to compare them, it's computationally expensive. It can take a long time to just run. So what you can do, especially on ones where you have to do 4 or 5, and compare them and ultimately pick which one is the best, what I'd do is I'd set up the whole problem, do all my steps, and then once I got to the point where I needed to do the model comparison of picking 4 or 5 of these, I would run them, start a new problem. I would save it and start a new problem, because by the time that finishes, that's going to be 3, 4, maybe 5 minutes. And every minute counts. You don't need to be sitting and waiting for this thing to finish running. You can start on another data science problem. You could start on spatial. You can start on chained apps. You can start on anything else and start building that problem. And then once your model's done, you could save that problem, come back to this, and so you're basically working and using every second, even though the problem itself is going to take a long time.
Matt, do you use caching much in that situation? Do you cache results?
Yep. So that's the next bullet point that I've got, which is caching your logic before and after your model run. So if I'm doing all my data prep, and I'm doing 3 data prep steps before my data science step, I'll cache all my data science or my data prep steps, so I don't have to rerun, especially if it's a large data input or it's computationally expensive. And then if I can check the box that my model output is what it needs to be in terms of I use the right models, I'm getting the right model object that I need, it's matching what I'm supposed to see, I'll then cache that. So I'll cache once I know the steps I've completed. I can check the box and say they're good. But I won't just cache for the sake of caching. I'll make sure that I cache that that part is good. And that's also kind of the programming equivalent of taking the problem that's got 8 steps and drawing a line through it. That's what cache does for me on this. Yeah. And then that way, if you need to prune maybe the score tool or some data prep after the score tool, then you don't have to rerun this whole object that takes 5 minutes or 10 minutes as a workflow. It runs in seconds. And then the final objective is to match the target output, the target objective. What they're going to give you is similar to the weekly challenges. They're going to give you a target data set of what this should look like. Now, it may or may not be the result you have to match exactly, but it's going to give you the schema. It's going to give you the columns you need. It's going to give you either sample rows or actual rows of what it looks like, and then making sure you take the time that are the columns there that I need? Are they in the order that I need? Is it the right data type? And then do I have all the records that I need? If it's like row level data, like tabular data. But if it's one where it's a number, like it's 10, and they tell you that you have to match the model object of 10, then just make sure that your result is 10. And if it's not 10, start working backwards. Go from step 8 to step 7, step 7 to step 6, step 6 to step 5, and then slowly start working your way back to where am I missing something. Because they're going to try and give you the framework. And once again, what can be confusing, which is why it's about reading the instructions, is that the output, if the answer is 10, it could say that this is a sample and that this is an example of what we want your answer to be. We just want a number. Or they'll give you a tabular data set of 5 columns, 4 rows, this is what it should be, and then just make sure you do that. And that's where you should be spending your time, doing that quality control check, that you know how to do the problem, you mechanically do it, just give yourself the time to make sure that your output is matching what they want you to do.
All very good advice, Matt. You made me think about something that happened back in the COVID years. Alteryx had asked me to help them design a Grand Prix. It was the first online Grand Prix, of course, because there was no Inspire. People couldn't get together, so I designed this Grand Prix, which was related to a global climate and global warming. So in the end, the final question, guess what? It was a predictive study. It was a predictive task. And I knew going into it that I was going to be dropping the hammer on the competitors because typically they didn't use predictive as the final exam question like you showed earlier. And I was trying to make a prediction of who would win it. I knew who the competitors were. I knew what their backgrounds were. And it turns out that an Alteryx employee won it, somebody who was very well versed in predictive. So I felt a lot of pressure there because I knew it was hard, and I was worried because they have a set amount of time to do it. It was a timed live event that we did. We captured it live streaming, and luckily someone solved it within the time frame. So I felt like I did a good job, but it was tight for a while. It put them through the ringer. So predictive projects or problems can put you under pressure. And the number one thing that I can give to people who are taking this exam, the one piece of advice I could give is give yourself a break. Don't beat yourself up. Everybody's in the same boat. Everybody's got to solve problems like this, and you've got the background to do it. Don't allow yourself to bring yourself down and think, oh, this is too hard for me. Just work it methodically, as you've mentioned, Matt, step by step, and take your time and read the instructions. Key items.
And I would say the final remark on this is I think predictive problems on the expert exam are more solvable than I would say some of the other problems. I think that there are problems that are easier and more difficult based on the range of questions or the depth of questions they can get. And because of the mechanical nature of predictive, where you're doing some sort of data prep, they're giving you clear instructions, you're feeding it into a model, just make sure you just follow the models they want you to pick. And then just spend some time with, model comparison and lift chart and anything where that looks at model A or model B, and just run them and just play around with the individual tools. Put the browse tools on, get used to how long these things run, get a sense of what they output, and just do a couple, practice problems with just using the sample workflows of the sample tools. And I would take them, I would put 4 or 5 of them in just a sample workflow, connect it to data, and then just connect it to a model comparison tool and just get the output and get a sense. How long does this run? What am I seeing in the model comparison? If I have to Google what's coming out of there, just get more comfortable with what's coming out of there, and you can solve this problem. This is one of the ones that I would recommend that people approach and tackle, and you should be able to do some practice, and it shouldn't be a huge lift to get from A to B. And I can't say that for every problem on this exam, where some is going to require, you're going to have to know your way around. You're going to have to know your way, especially with spatial. You're going to have to know your way around the block and know depth and breadth and be able to really do a lot of critical thinking. That on these types of problems, it's more, like I said, procedural. So Ken, thanks very much for joining me on Regression, and look forward to seeing you on future episodes. So take care.
Thank you, Nat. Bye-bye.
Bye.
Let's make sense of this.
Let's make sense.